Hello, Year 11. Hopefully you had a lovely half term, and now we're back into it. We've pretty much finished this topic. The last thing we need to do is momentum before we do some revision. So we'll get straight into it. There's today's work folder, and here is the PowerPoint. Now, this lesson gets pretty difficult at points. So as long as you get the equation and can put numbers into an equation to get a value for momentum, and you remember the unit, that is all that I want you to do. Because a lot of the collision stuff is higher tier, like actually calculating it, but I need you to understand how collisions work in terms of momentum. So, I'm sure you would all understand that if you had a horse and a small child running towards you, the small child would be easy to stop. And why is that? It's because momentum is how difficult something is to stop, essentially. Now, momentum is affected by two things: the mass of something, so the larger mass of an object, the harder it is to stop, okay, or the larger the mass is, the larger the momentum, and the velocity, so the faster the object moves, the more momentum. Okay, so that's pretty straightforward. But the next one is we need to know this equation here. Momentum equals the mass of that object times by the velocity of that object. Now, mass is measured in kilograms. Velocity is measured in meters per second. So the unit that you use, okay, is kilogram at meters per second. And let's see. So if I had something that was a mass of 10 kilograms and it was going at 5 meters per second, to get the momentum I would multiply them together, so it would come out as 50, and the unit would just be kilogram meters per second. You just write it all as one thing. Okay, so let's do some questions. If you want, you can pause the video and try and work through them yourselves. If not, just listen to me go through them. We're going to have a few examples later as well. So number one, remember, momentum equals mass times velocity. And remember, speed and velocity are essentially the same thing. It's just velocity is the vector and speed is the scalar. So if you see something like this, okay, there's my mass. So I've got 1 kilogram times by 10 meters per second. Remember, that there just means the same as this, which equals 10 kilogram meters per second. Or you could write it like this. Okay, it means the same thing. So what I did there, 1 kilogram ball traveling at 10 meters per second. The momentum will equal the mass of the ball times the velocity of the ball. We know the mass is 1. We know the velocity is 10. So we just multiply them together. And as you see, they're all just going to be the same. You're just going to multiply two numbers together. So in this case, we've got 1 to 50 kilogram car that is traveling at 30 meters per second. So my car has a mass of 1250 kilograms, 1250 kilograms, and it is traveling at 30 meters per second. So 1250 times by 30 equals 37500 kilogram meters per second. So let's have a look. A 25-gram pencil case being thrown across the room at 5 meters per second. Now, remember we said that the mass has to be in kilograms, okay? Here, the mass is not in kilograms. We should know that there are 1,000 grams in 1 kilogram, okay? So if I've got 1,000 grams and I want to turn it into 1 kilogram, I have to divide by 1,000. Okay. So the same goes for if I have 25 grams and I want to turn it into 1 kilogram, I have to divide by 1,000. So I get 0.025 kilograms. Okay. So let's do this one. Well, we now know that it's 0.025 kilograms. And the speed of the pencil case is 5 meters per second. Times that by 5, and we get 0.125 kilogram meters per second. Last one, 75 kilogram bungee jumper falling at 40 meters per second. So again, 75 times 40, that's a 40. 75 times 40 equals 3,000. 3,000 kilogram meters per second. Now, this is essentially all you need to do. You may have to rearrange it to calculate the mass of something or calculate the velocity of something if you are given the momentum. Other than that, if you can remember how to calculate the momentum, and probably more importantly, you can remember the unit of momentum because it's something that is always forgotten, you are absolutely set for this section of the topic. So let's have a look. This next bit here is to do with collisions. Now, I just want you to understand the collisions, and if you can't do the calculations, that's absolutely fine. So, for this next bit, I just want you to listen, and I'll explain how collisions work. But you need to know this fact here, okay? This fact. Momentum is conserved when no external forces act. So, for example, if you have a situation, let's say two people are running towards each other, the momentum before they collide is going to be the same as the total momentum after they collide, right? Now, that might be a ticky box question, you just have to remember it. They might ask you that momentum is not always conserved, and why is that? You could give an example of, so an external force could be something like friction, or so you're losing some of the energy to the surroundings. Okay. Now let's take an example of a collision here. So, two cars are racing around the track and they collide with each other. The blue car hits the back of the red car. Upon impact, the cars stick together. What speed do they move after the collision? Now I'm going to exit this. Okay. I'm going to go onto here so we can see a bit better. Right. Now, so in the question we had a car that, so we'll just do it as a box, and it was going at 20 meters per second in that direction, and it had a mass of 1,000 kilograms. There was another car that was traveling at 50 meters per second in that direction and had a mass of 800 kilograms. Now, if this continued to happen, there will be a collision because the car that's behind is going faster. So, we know that these are gonna collide. Now, so this is before collision. Yeah. So I'm going to split it in two. We're going to have before the collision and then after the collision. The question said that both cars will stick together. Okay. This car was at 1,000 and this car was 800 kilograms. Okay. And it said, what will the speed be afterwards? Now, what we'll do is let's work out the before. So what is the momentum before the collision. Right? Let's just say, for this example, it makes it easier if I tell it, if I define that this way is positive, and that would mean that anything that's going this direction would be negative, but nothing will end up going in the right direction, so we can ignore it for now. So I'm going to say that this direction to the left is positive. So what is the momentum before the collision? Well, let's have a look. Momentum of car 1, so I'm going to call this car 1 and this car 2. Car 1. So the momentum equals 1,000 kilograms times by 20 meters per second. Okay, so that is 2,000 kilogram meters per second. Right? So I just multiply the numbers together. So what about car 2? Do car 2 in a slightly different color. So car 2. Well, the momentum equals, well, it's got 800 kilograms, and it was going at 50 meters per second. So car 2 had a momentum of 40,000 kilogram meters per second. So even though car 2 is 200 kilograms lighter than car 1, because it's moving at a faster speed, it actually has a higher momentum. So in this case, because they're both going to the left, we can add those momentums together. So what is the total momentum before the collision? Total. Right, so let's make that total. We'll add them both together. 20,000 plus 40,000, and the total momentum equals 60,000 kilogram meters per second. That is the total momentum before the collision happened. Now, what we told you before on the PowerPoint is that the momentum before will equal the momentum after, okay? Because momentum is conserved. And in this case, we're assuming momentum is conserved. Now, before the collision, we had two different cars traveling at different speeds, and they crash into each other, they collide. Afterwards, they're both stuck together. So, we know the momentum after will equal 60,000. Okay, because we calculated it from the first half. Now, if I write down the equation, momentum equals mass times velocity, well, we know the momentum is 60,000. We know the mass of this vehicle, okay? If you look, these two cars have stuck together, so they now have a mass of 1,000 plus 800 kilograms. Okay? Just imagine it like you put the smaller car in the bigger car's boot. The whole car has a bigger mass, right? Because they've stuck together after the crash. So I know that the mass is 1,800 kilograms, and that will be times by the velocity, which we don't know. So then, if I need to get V equals something, okay, if I need to get V by itself, so I want V by itself here, so V equals something, I have to get rid of this 1800. We have to do the inverse of times, so whatever the opposite of times is, that's divide. So I'm going to divide this side by 1800, and I'm going to divide this side by 1800. And then what happens is these two cancel out, and I'm left with V equals, and 60,000 divided by 1,800 equals 33.3 recurring meters per second. Okay, so that is a collision question. All I need you to understand from this is being able to calculate the momentum of something. So here, calculating the momentum before the collision, you pick car 1 and you calculate the momentum. Yeah, so there's car 1. Then you pick car 2 and calculate the momentum. If you can do that, you'll be absolutely fine. Okay. Then if you're wanting to push it to a higher grade, giving the total momentum of this collision before and saying that momentum is conserved. Now, that is about as far as I want you to take it. I just wanted to give you a nice example of a collision. Now, I'm going to go onto this worksheet here. And you can see there are some questions. Easy, medium, and hard. Okay, I'd like you to pick 3 questions and do them. Okay, pick any 3 that you'd like. Preferably choose 2 columns. Okay, so maybe you want to do 2 from the easy column and then 1 from the medium column, right? That's what I prefer, but if you're really struggling, you can do all 3 from the easy. If you want to challenge yourself, you can try some of the hard ones. Okay, after you've done that, take a photo or upload your documents and email it to me, please.